Hi, I'm Mr. Dale. I'm a chemistry teacher at Emerson Junior Senior High School in New Jersey. And this video is dedicated to chemistry teachers and to generally to science teachers. And I just want to talk about the next generation science standards. Today's experiment has to do with light. So it's a natural phenomenon you can talk about. You can show a video on light. You can turn on light in your classroom. And you can talk about how electrons get really excited. And when they fall back to their ground states in the atoms, they actually produce light. So I want to do a simple experiment today. And this experiment has to do with burning magnesium ribbon. All right, I'm looking at my paper on next generation science standards. So during the lesson, what I do and what I encourage you to do is to encourage students to ask questions and to define problems, develop and use some models, planning and carrying out investigations. When I do my experiment now with the next generation science standard, instead of giving the students the procedure for the experiment, we develop the procedure together, right? So you get the students involved. Then we analyze and interpret data, etc. So hopefully you have your list of all the Dimension 1 practices, Dimension 2 cross-cutting concepts, etc. Okay? So I'll put this away and we'll get started on today's experiment. So what I have in front of me today is my magnesium ribbon. I have a new set of magnesium ribbon inside my container. I have magnesium ribbon that has magnesium oxide on the outside. So what I do, I get my students to remove the oxide layer using a piece of sandpaper, right? And this is a physical change, which is something which can be discussed with students also. I also have my crucible towns and I have my flint lighter. Okay, so let's get started. I have my burner over here. We'll go ahead, light the burner. Okay, so we have the burner. I'll move this away and move my sandpaper away. Here we go. We'll take a piece of magnesium ribbon. Right.
Ms. Brock, please contact the main office.
And here we go. All right, I'm grabbing the piece of magnesium ribbon using my crucible towns. I'm now going to hold the piece of magnesium ribbon in the burner flame. I will look away because it's so bright, and you'll be able to observe what happens. And you can make sure you warn your students not to look directly into the light. And then you can have a discussion as to why. All right, here we go. Okay, so the magnesium ribbon is burning right now, producing a brilliant white light. You can think about all the valence electrons that are getting really excited by the flame. And the electrons are jumping up, falling back, up and down. And as the reaction is proceeding, you notice white fumes are being produced. And now I have a light white ash. Okay? And the ash falls on the tabletop. And you can have a discussion about the composition of the white ash also. Right, let me turn off my flame. Alright, so that's a simple experiment. It's burning a magnesium ribbon. I'm now going to go up to the board and we'll have a look, see what the equations look like for this particular reaction. So we were talking about burning magnesium ribbon. So we have magnesium, which was a solid, reacting with oxygen gas and in the presence of flame. And you can ask students to kind of deduce what's the formula for magnesium oxide. And you can walk them through this. Magnesium ions, Mg plus 2, oxide ion is 2 negative, you balance the charges, positive or negative, and your formula is MgO. Now there's a second reaction that occurs. Magnesium also reacts with nitrogen gas in the atmosphere. Remember, the atmosphere is almost made up of 80% of nitrogen gas in the presence of flame, and you get magnesium nitride. Here again, you can have a discussion about the actual formula for magnesium nitride. You have 3 magnesium 2 plus ions, 2 nitride ions, you balance the 6 pluses with the 6 negatives, and you end up with the formula Mg3N2. Alright, so this is a simple experiment. What I do in class, preparing, discussing all of this, probably take about 2 periods, carrying out the experiment, and having a long discussion and data analysis on what we've done in class. So it's a really exciting experiment. My students love the experiments. Hopefully you try it out, and hopefully you're successful.